Welcome back, students. Video 6B. Let's run through an example with a designed experiment. This one's a little bit more traditional than our math, developmental math redesign here at Cecil College. Okay, we've talked steroids before for Major League Baseball. If you remember back to lesson 5, we called the 50s and 60s the golden era of baseball, where we don't believe anybody was taking steroids, and we called the late 90s and early 2000s the steroid age, and we could go on the internet, find home run totals, see which era hit more home runs. Now let's design an experiment to test if taking steroids, and I threw in an extra wrinkle here, human growth hormone. We'll abbreviate that HGH. I wanted to have two things that we were manipulating just to have a little bit more of a richer example. Design an experiment to test if taking steroids and or human growth hormone, two separate things, would cause Major League Baseball players to hit more home runs. All right, so we'll go over to the board here. You've got a whole page to write it. It's going to be a big diagram, lots of stuff labeled. So just sort of space it out on the page as best you can. One thing to keep in mind, this is completely illegal. I think steroids are illegal, plus they're illegal in Major League Baseball. This is probably unethical, but I think it makes for a real nice example, so we're just going to do it anyways, okay? I guess baseball's about over. We're taping this in October, so coming up for next season, we will secretly recruit. We have to secretly recruit because not allowed to take steroids. We'll secretly recruit, say, 200 baseball players. That's a pretty darn big sample size. I'm not sure how many players are in the entire major leagues, but that's going to be a good chunk of them. This makes the numbers work out nice, if you're wondering where the 200 came from. Okay, I have two factors that we're going to look at. There's two factors. Okay, one of the factors is steroids. And we'll get to the definitions in the next video. I like to do an example first. And for steroids, one of two things can happen if you're part of our study. Either you're going to get them or you're not going to get them. So we'll put a yes or no here. That's one factor. The second factor is whether or not you get human growth hormone. Okay, so second factor here, HGH. And again, either you're going to get that or you're not. And what's going to happen with two factors, and each factor has two levels, is really what we're going to create is four groupings here. Some players will get steroids as well as HGH, be sort of the yes-yes group. They get both drugs. Some players will get only steroids, no HGH. Some players won't get steroids, but they will get HGH, and some players will be no and no, will be clean, is a good word. Okay, so we start with 200, so here's what's going to happen. A good experiment, we need to randomize. So at this step, I'm going to chop my 200 players randomly into 100 and 100. I'm going to just write here off to the side that this part needs to be randomized. I can't certainly let players choose, hey, do you want to be on steroids next year? Because maybe some players on contract years or power hitters might want to be in the steroid group. Maybe some clean players or I don't know, those who have an ethical personality won't want to be on steroids. But we're going to let the flip of the coin determine what happens. 100 players. 100 players will be on roids for the whole season. 100 players, this will be the yes. Can I fit steroids? I'll just put roids here. Yes to roids. Apostrophe or something there. The flip of the coin. I'll flip coins, and the first 100 heads, guess what? You're going to be in this group over here. That leaves 100 players on this side of the fence. This will also be 100 players. And these are the no roids. group. We have to randomize. Randomization is key to run a proper designed experiment. Okay, that's taken care of one factor. We do have the second, it's HGH. We're going to flip coins again. Out of these 100 players, we're going to break it down one more level. Again, this is random, and then this will be also random. We'll flip coins. First 50 players. Who get ahead, those 50 players will also get yes, HGH. You can sort of see why I picked 200. Nice numbers I can divide on the fly here. Those that didn't get put randomly into the HGH, 50 players will be clean when it comes to HGH, so this will be no. HGH. You know what's going to happen on the no-roid side, right? We'll do the same thing over there. So again, this is random. We'll break these 100 into two groups. These folks will, yes, 50 players. 50 players. Yes, HGH. And these 50 players here, no HGH. All right. This is going to get filled up with all kinds of notations, but I want to use the proper terminology. These four groupings, these are called treatments. Treatments are the combination of the factors that you're receiving as a participant in this illegal and unethical study we're running here. But again, we want to get to the heart of, does taking steroids cause you to hit more home runs, right? I can't really prove that conclusively with an observational study. I would have to do this, statistically speaking. All right, these are called treatments. I'm thinking back to the principles of a good designed experiment. Good designed experiments need to control certain things. Maybe we can put a little list of, put in the box here off to the side. Well, I'll call this controlled. I'll just say variables generically. The idea is this. I really want to get to the heart of, is it the roids that cause you to hit more home runs, or possibly the roids and HGH? I want to figure out which combination does that. I need to control some things. The 200 players aren't going to like this, but for this experiment, we know this is fake, right? We're making this up. These players will be forced to use the same equipment all year long. We're going to control the bats that they use. Everybody will have to use the same bats, same batting gloves, whatnot. We will force these Major League Baseball players to be put on the same training program. So everybody hits the gym for the same amount of time each week. Well, what, we're really going to irk these guys. How about same diet as well? They had no idea what they were getting into when they signed up for our study here in MAT127. So we're going to control some things. Realistically, you see this would never work, right? Imagine trying to control 200 baseball players. Same equipment, same training program, same diet. We've got our control. We've got our randomization into treatment groups. We definitely have replication. I have 50 players in each group. Okay. Think about doing this with maybe just 4 players. One player goes here to the yes. One player goes here to the roids only. One player goes here to the HGH. And one player is the, we could call it a baseline or a control group, for example. If I had 1, 1, 1, and 1, and this guy ends up hitting a ton of home runs, would I be able to conclude that it was the roids or the HGH? And the answer is no, right? I need more data to feel comfortable making conclusions. So we started with 200, we got 50-50. That's replication there. So we can check that off the list. All right. We have to think about that blocking factor. Blocking factors are not random. Okay, the treatments that you're assigned to, that is random, but a blocking factor is not random. You may or may not be aware, but in baseball there are two leagues, American League and National League. In the American League, we'll abbreviate that just AL, there is a designated hitter. Lots of abbreviations here, DH, it's not important. But essentially in the American League, there's one more specialized hitter in the lineup. Couldn't you see that the American League might have more power hitters? Because on all the teams in the American League, there's one extra specialized hitter, the DH. Over in the National League, pitcher's bat. Because the pitcher's bat, it means there may not be this extra spot for power hitters. So you could make the argument that overall, there may be more power hitters in the American League who might hit more home runs. So, what I'm going to do is block by league. I'll write it in the middle here. We'll do a block by league. And the reason is I think that league might have something to do with a player's ability to hit home runs. If by the flip of the coin, lots of these players, my 50 players that are both on roids and HGH, if the flip of the coin, we get unlucky and say there's 30 American League players and only 20 National League, could happen, right? I'm not going to get exact equal AL and NL here, 25 and 25. It could be that just the flip of the coin put too many of those American League players in one group. I want to make sure that I have accounted for that. I'll do a block by league. And essentially what that's going to be is, as I'm creating my random treatment groups, I will just ensure, I'll write it as simply as I can, I'll just ensure that I have equal representation. Equal representation of both AL and NL, American League and National League, here, 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 and here. In the real world, you may not get equal treatment groups. You might not get a nice 50, 50, 50, and 50. You might not get a nice 100 and 100. You might have an odd number of players, for example. So for this example, the sample sizes in each group are nice and clean. I guess I would have 25 and 25 for each of these groups, okay, each of the treatment groups. All right, lots going on here. We did randomization. We thought about a blocking factor that might affect our results. We thought about some things that we can control, right? We've got replication. And so we've hit basically everything that you're thinking about to run a designed experiment. What I'll close with is this. What am I going to measure at the end of the season, right? I have to measure something. And while we're seeing what happens with home runs, right? So for this treatment group, I've got 50 players. I don't have much room to write it, but I can squeeze it in here and just say, do the same thing for all 4 of them. But for each group, I have home run totals for 50 players. And again and again and again. How can I summarize that? Take those 50 numbers and summarize it into one number that might sort of tell me about how many home runs are hit. We calculate the average, right? For each group, hope you can see this on the video, but I will calculate the mean. And what we'll do is we'll end up analyzing the means. Okay, so I'll just say it. I won't write anything down, but just think about this to close. If this group, say on average this group hit 19.5 home runs, and maybe the second group here, maybe they hit 19.2 home runs. The HGH only group, maybe they hit 19.9 home runs, and the clean group hit 18.8 home runs. these average home runs are very similar. And would you feel confident saying that, well, because this mean was the highest, that that's the best combination? Sort of feels too close to call, right? So your common sense, and it's a concept called statistical significance that we'll get in with the definitions. But what we're looking for is for the data to convince us. If one of these means, say this HGH and Royd's group, their average home runs is like 5 or 10 more than any of the other groups, then I think beyond a reasonable doubt, we would conclude that, well, yes, being on Royd's and HGH seems to be causing players to hit more home runs. We ran a good experiment, we randomized, and that treatment group is very different from the remaining. Okay? So we don't have room to put any numbers here, but I hope verbally you can understand what we're getting at. As we move on to the next video, we'll get into the definitions and we'll actually throw some numbers to an example just like this. Okay, thanks for watching. See you next time.